Last time, we cracked open how an AI learns. Now a stranger question: how does a machine turn a sentence into a picture? Start with a number that should bother you. Stable Diffusion, the model that lit the fuse on AI images, cost about $600,000 to train. Then they open-sourced it, and the price of making a brand new, photo-quality image collapsed toward zero. No camera, no illustrator, no stock license, just a sentence. But here's the part nobody tells you. This thing is not a painter, and it has no library of pictures to copy from. It removes noise, and it copies nothing. In the next few minutes, we show you exactly how a line of text becomes pixels. Define it cleanly. Generative AI produces brand new content, images, text, audio, instead of labeling what already exists. A classifier looks at a photo and says cat or dog. A generative model does the reverse: you give it the words, and it invents a picture that fits. Here's the mental shift that matters most: it is not searching a database for the closest match. It learned the statistical patterns of billions of images, and from that it samples something that never existed before. A prompt isn't a photo library lookup, it's an instruction to dream up new pixels. Generate, not retrieve, that distinction is the whole field. Before Diffusion 1, the field tried 3 approaches, each leaving a gift. VAEs, from 2013, squeeze an image into a tiny code and decode it back, stable and fast, but blurry. GANs, from 2014, pit 2 networks against each other: one forges images, the other hunts the fakes. They gave us the first genuinely sharp faces, but they're brutally unstable to train. Diffusion, made practical by the 2020 DDPM paper, adds noise and learns to reverse it, high quality and stable, which is why it took over open image generation. And the newest, autoregressive models, build an image piece by piece like a language model. That's OpenAI's GPT Image Gen. The punchline: GANs gave sharpness, VAEs gave latent space, diffusion fused quality with stability. Stable Diffusion is the hybrid of 2 of them. Here's the one idea that makes diffusion work, and it's beautifully simple. Take a real photo, add a little random static, then more, and keep going until the image is pure noise, television snow. That's the forward process, and it takes zero intelligence. It's just a fixed recipe for destroying a picture. Now flip it. Train a network to do the reverse: given a noisy image, predict the noise and subtract it. Do it once, the picture clears slightly; do it dozens of times and you walk all the way back from static to a crisp image. That trained denoiser is the entire generative model. And here's the twist that makes it generative: to create a new image, you don't start from a photo. You start from pure random noise and ask the denoiser to imagine its way out. Now wire the whole machine, the way Stable Diffusion runs it. Your prompt is a string of text. A text encoder called clip turns it into a vector of numbers, a mathematical fingerprint of your meaning. The model starts from a small square of random noise. Then the engine, a network called a UNet, looks at the noisy square and the clip fingerprint together and predicts the noise to remove, nudging the image toward your words, 20 to 50 times. The newest models, like SD3 and FLUX, swap the UNet for a transformer, a DIT, but the job is identical. Finally, a VAE decoder expands the result into a full picture. Prompt, encoder, noisy square, denoise, decoder, image. And the one dial you actually turn, classifier-free guidance, controls how hard the output obeys your prompt versus how creative it gets. So why is it called latent diffusion? Here's the trick that put Image AI on your laptop. A 512 by 512 color image is nearly 800,000 individual numbers, and denoising all of that on raw pixels is brutally expensive, so Stable Diffusion doesn't. The VAE compresses the image into a tiny latent grid, 64 by 64 by 4, about 16,000 numbers, and every denoising step runs in that compressed space, where the math is roughly 48 times lighter. Only at the very end does the decoder blow it back up to full pixels. Earlier diffusion models needed a datacenter. By moving the work into latent space, Stable Diffusion brought near state-of-the-art generation down to a single consumer graphics card. The reason you can run this at home is one word: latent. Ground this in real numbers, all cross-checked. The original Stable Diffusion is just under a billion parameters. SDXL jumped to 3.5 billion. SD 3.5 large hit 8. And the current OpenWeights leader, FLUX.2, shipped November 2025 by the Stable Diffusion team at Black Forest Labs, is 32 billion. In 3 years the open frontier grew 30-fold. On data, they learned from LON5B, nearly 6 billion image-text pairs scraped from the web. And the steps fell as the models grew. The 2020 method needed about 1,000 denoising steps per image, modern samplers do 20 to 50, and distilled models just 1 to 4. Bigger models, cleaner output, fewer steps, that's the whole trajectory. So which tool should you use? They split by philosophy. Stable Diffusion and its open siblings, SDXL, SD 3.5, FLUX, are open weights, run them locally and customize everything, with FLUX.2 the OpenWeights quality leader. The power users tools. Midjourney is the opposite, completely closed, its own private model, tuned for one thing, sheer beauty. OpenAI's GPT Image, inside ChatGPT, is autoregressive, and its superpower is obedience, following complex instructions and rendering readable text. In one comparison it placed objects correctly about 89% of the time versus Midjourney's 62%. And Google's Nano Banana became the 2026 default across Gemini, Search, and Lens, with the world knowledge to keep facts and characters consistent. For philosophies, Stable Diffusion and FLUX are control, Midjourney is beauty, GPT Image is obedience, Nano Banana is knowledge. This isn't a lab demo anymore, by 2026 it's wired into the everyday creative stack. Adobe Firefly, built into Photoshop and Illustrator, had generated over 24 billion images by mid-2025. Canva's Magic Studio AI tools have been used more than 10 billion times. And in Adobe's October 2025 survey, 86% of global creators said they now use generative AI, over 40% of them daily. Where does all that output go? 7 places: graphic design and marketing, the #1 use, ad campaigns, A/B tested at scale, e-commerce shots without a photo studio, game concept art, stock imagery, the business Getty is fighting over, architecture visualization, and film pre-visualization. The pipeline you just learned is now a button in the tools a billion people open every day. So where does this go? 5 fronts. Real-time, few-step models now generate under 1/10 of a second, fast enough to draw live as you type. On-device, the model is shrinking to fit your phone, generating and editing offline. Consistency, the same face, the same product, held steady across 100 images, the single hardest unsolved problem. Beyond flat pictures, the same denoising trick is jumping to 3D and to world models, exactly where our next video on AI video begins. And the regulation wave, the EU AI Act's Article 50 takes effect August 2026, requiring a machine-readable label on every AI image, with C2PA content credentials the named method. But here's the tell, a 2026 study of 50 systems found only 38% embed any mark. Quality is basically solved. Trust and provenance are the unsolved frontier. Now the part the hype skips. These models learn from billions of images scraped off the open web, overwhelmingly without consent or payment. That's not a side issue, it's the foundation. Getty Images sued Stability AI in 2023, claiming more than 12 million of its photos trained the model. In November 2025 the UK High Court mostly sided with Stability, rejecting the core copyright claim, but in December it granted Getty permission to appeal, so that question heads higher in 2026. And in the US, the artists' class action, Anderson vs. Stability AI, survived dismissal, with trials set for September 2026. So the first round leaned toward the developers, but nothing is settled. Hold both truths at once, this technology is extraordinary, and it was built on data nobody asked for. Lock in the takeaway. The machine is demystified, a noise removal model working in a compressed latent space, steered by a text fingerprint, decoded into pixels at the end. And here's the strategic kicker, the architecture is not the moat. Diffusion math is public, the papers are free, the weights leak open within weeks. So who wins? 2 things. Data, rights cleared, well-captioned images at billion scale. And distribution, being the default button inside ChatGPT, Photoshop, or Discord. The next leader won't be whoever invents a slightly better sampler, it'll be whoever owns the cleanest data and the default surface. The math is free. The data and the distribution are everything. So the next time an image appears out of a sentence, you'll know it isn't magic and it isn't copying. It's a machine that learned to remove noise, running tiny in latent space, steered by your words. Next time you generate, picture it, pure static slowly resolving into your prompt, step by step. That mental model is the whole field. And next, we take it one dimension further, how the same noise removal trick learns to make a still image move, AI video. If this made the black box a little less black, subscribe to Technologia today. We read the paper, then tell you what it actually means.